question that had been asked in JEE Advanced 2024 paper 1. And the question is as follows. We have two functions. We have been given two functions, fx and gx. And using these two functions, they are defining a new function, which is again a real valued function, and has the domain R. So it is somewhere. It is obtained by using these two functions only, and based on these, and we have four constants A, B, C, D. Or these are not constants; they can vary, of course, but depending on the part P, Q, or RS, they have fixed the A, B, C, D. So we have to match each part P, Q, RS with the correct option. 1, 2, 3, 4, 5. Okay, so before moving on with the question, just first see what F and G are actually giving us. Because we have to see whether G is H is 1, 1 on 2 differentiable and the range of H at every point. So we can see, first of all, what F is saying. So F is this function. So F is x mod x sine 1 by x, where x is not 0. And if x is 0, we are getting 0. So we can easily get away with this modulus function. We just need to use a definition of modulus function. So if x is greater than 0, mod x is greater than, mod x is actually x. And if x is less than 0, mod x is minus x. The work of mod x is just to make the quantity positive. So if x is less than 0, modulus will try to make x a positive value by adding a minus sign. So fx becomes fx is x square if x is greater than 0. If x is less than 0, x square is minus x square. And if it is x is 0, then it is 0. So is f continuous or differentiable? So we can see that we can check the left hand limits and the right hand limits. Now, when x is not 0, then this is just the product of two continuous functions, x squares and sine 1 by x. When x is less than 0 or when x greater than 0, then we can see that this is the product of two continuous functions. So of course, this is continuous. But what about the point x equals to 0? Is f continuous at 0 also? That means we need to check the left hand limit and the right hand limit. Now, so you can see that here the definition of function is minus x for sine 1 by. So this is just going to be a finite value between minus 1 and 1. And this goes to 0. So the product goes to 0 because this is finite in this case. Similarly, you can also check for the right hand limit. You will be getting 0. And since the function takes value 0 at 0, so this is a continuous function. F is a continuous function. For greater than 0 and less than 0, it was easy because it is product of two continuous functions. Only the point which was to be checked was x equals to 0. And of course, it is continuous because we are getting the LHL equal to RHL equals to 0, and this is 2 at f0. So f is continuous function. Now checking our next function, which is gx, and this is 1 minus 2x when 0 is in this interval 0 to half, and otherwise 0, g is 0. Okay. So now see this in this function. Yes. So what this function is saying that it is a very good practice if you try to solve these questions using the graphs, because just solving them without these graphs will be very difficult. You need to look these questions very quickly and get a final answer. So in order to solve these type of questions where you have different functions given, always try to draw the graph, because it gives you a final answer very quickly. So it is saying that between 0 and half, you are getting the function 1 minus 2x, and rest everywhere it is 0. So if we plot it like this is half, this is 1, this is 3 by 2, this is 2, and this is the negative real axis. This is 1. Okay. So this is a linear function. Linear. It will be a straight line. So just to know where or the straight line, you just need to have 2 points, and after you join them, you'll be getting the line. So instead of looking at all the points between 0 and half, you just need to check where the function is at 0 and half, and then join the 2 points so that you have the line, because G is the straight line, or the graph of G will be a straight line, or it is a linear function. So at 0, you are getting the value 1. Substituting here. 1 minus 2 into 0, it will get you 1. At half, it is taking the value 0. So these are the 2 points, and you just need to join them. This is a straight line. This is the straight line. And rest everywhere after half, after this point half, and even for the value less than 0, it is taking the value 0. So it is not going anywhere. It is just a 0. 0. This 0 function. Okay, now is G continuous? And you can easily see that when x is lying between 0 and half, then G is continuous, since it is a straight line. It is a linear function there. So it is continuous. What about the point half? Now half, the value at half is 0. And after the value, after half also, it is 0. And it is approaching using a straight line. So at half also, it is continuous. G is continuous at half. So G is continuous at the value half. After half also it is continuous because it is constant value. And before 0, that is for the domain points less than 0 also, it is a constant value. It is taking the value 0 only. So it is continuous there also. Only the point, it is also very much visible from the graph itself that for the value 0, it is taking one value, but for the values less than 0, it is taking 0 value. So it is not continuous. There is a break in the graph. Here it is 0 and here it is 1. So you can't join it without, join these points without lifting your pen. You need to lift your pen, I mean. You need to lift your pen to join, because to draw this line to, because it is taking value 0 here. And at the point 0, it is taking one value. So you're not going to join these points because it is a discontinuous graph. So at 0, it is discontinuous. G is not continuous at 0. Just everywhere it is continuous. Okay. Now moving on to the question. What the question says. You have defined a function h using f and g. And we have to match the P, Q, R, S to the correct options. So first have a look at the part of P. it says that A is 0, C is 0, D is 0, and just B is 1. So what is H in that case? Only this remains because rest all three values are 0 of A, C, and D. So only this remains, and B is 1. So Gx plus G half minus X. Okay. So now we need to see whether H is 1, 1, 1, 2, or differentiate. We have to check the range of H also. Since P is taking the value either 4 or 5, the correct option is either 4 or 5. So we will be focusing on that only. But we need to check the range for this H function. Okay, now G is fine. But what about this function G1 by 2 minus X? But actually what it is? Let's see. G1 by 2 minus X. What is this? So you know that when X was between 0 and half, G is non-zero. Only for these points of the interval, closed interval, G is non-zero. And for the other points, G is 0. Only for these points, G is non-zero. Now what is this? What is this? So this is a composition function. You can write it like this. G composition Qx, where Qx is this linear function. This is this composition function because earlier G was choosing the points of the real axis directly. You can substitute or you can act G on any point of the domain real, which is real line. But when G and the domain points are given by this, that means X on any point of the real line, first Q will act, and then you will be getting Qx, and on this point G will act. So G is not acting directly on the domain points, it is acting on R via Q. So Q is the mediator, or Q is acting between them. So what type of value this function G 1 by 2 minus X is going to take? Now you know that, you easily know using the definition that G will be non-zero only when X lies between this. Now since the domain point is given by this, so what condition should be on 1 by 2 minus X for G to be non-zero? So if 1 by 2 minus X lies between half and 0, then G 1 by 2 minus X will be non-zero. Because earlier when X was lying between 0 and half, there G was taking, because it was given by Gx, non-zero value. Now, since they have just changed the domain points, you just need to take care of this. If you see this as variable y, you substitute half minus X as y, then you know that this is nothing but the function gy, and this will be non-zero once y is between 0 and half. So this is what we are doing. So since y has this value, so half minus X should be between 0 and half for G to be non-zero. Okay. Now, what values are we getting for X using this? So this is nothing but, and you multiply with the negative sign, you get the inequality reversed. Or in this case, G is non-zero when x is not half, because when x is half, G is 0. So here also we'll be changing it just half. 0. And this. So this is a coincidence that when x is between this, although 0 is not included, half is included this time. So G 1 by 2 minus x will be non-zero. And for rest all the values, it will be 0. Okay. So now we will try to draw this function. This is 0, this is half, this is 1, and rest everywhere. After half and before 0, it is going to be 0. So you need to take care of only these points. Okay. Now again, G 1 by 2 minus x is, I told you, this is G composition with QX. This is linear. Q is linear function. And G is also linear function. So we know that composition of two linear function is a linear function, always. So this is a linear function. And also we need to look at only the points lying between 0 and half, and 0 and half both are included. That means the points of the closed interval. After that, or G is 0. G 1 by 2 minus x is 0. So how will you plot this? Now you know that G was this line. At half, it was taking the value 1, G, the original function gx, and sorry, at half, it was taking the value 0, and at 0, it was taking the value 1. It was this line. Now, what is 1 by 2 minus x doing? And since we need to look only for the points 0 and half, so we'll check what are we actually getting. Or first, what is 1 by 2 minus x given? You can see. Now you will see. So where is 0 going? Where is 0 mapped by this function is q. So what is q0? 0 is mapped to half. You can easily substitute here. You'll see half. Where is half going? This is 0. So that means 0, half. And when you plot it using q, so 0 becomes half and half becomes 0. You can see easily. 0 becomes half and half becomes 0. And for all the points between 0 and half, this is happening. If this is, for example, 1 by 3, then this becomes 1 by 3 minus nothing but 1 by 6. So this becomes 1 by 6. And what does 1 by 6 becomes? This becomes 1 by 3. So this is happening with all the points between 0 and half. 0 becomes half using q and half becomes q. Similarly, these points, the points get swapped with something else. So you don't even need to look at that. You can easily say, or you can easily plot the graph of G 1 by 2 minus x using very limited information also. See, Now, where is 0 going? Using this 0 going to half. So, at 0, it is taking the value g 1 by 2, which was 0. Now, you have to look at the definition of g, which was nothing but g x was 1 minus 2x. So, now since 0 becomes half, using 1 by 2 minus x, it becomes half, and at half, it was taking 0. So, at 0, it is taking the value of 0. What about half? Again, I said that the composition of linear function is linear function, and g1 by 2 minus x is the function, composition of the function gqx. This is a linear function because it is given by 1 by 2 minus x. And this is also a linear function. And we are talking about only the points of this domain because this is where it is actually showing some value, otherwise it is 0. So on this domain only, this g is linear and q is linear everywhere, but g is linear only here. So on this domain, g composition q will be linear function. So again, if you know 2 points of the domain, 2 points of the line, linear means a straight line. So you'll be able to trace the entire curve or the line. So and half, where is half going? Using this, half becomes 0. Half minus half is nothing but 0. That means g of 1 by 2 minus half is g0. And at 0, it was g is taking a value 1 using 1 minus 2x original definition. So here it is 1. And since now it is a straight line, and 2 points of a straight line joined. This is the function g1 by 2 minus x. Rest everywhere, it is 0. It is 0 everywhere. Okay, now we have to see the addition or the sum of these two functions, gx, g half minus x. And we know that both are taking a non-zero value only between 0 and half. Rest everywhere, both the functions are 0. So no need to check anywhere else. That will be 0 because this is 0 outside this interval. This is 0 outside this interval. So no, just need to check the values here. Okay. So what is the definition of gx on this interval 1 minus 2x? And if you try to obtain the equation of this straight line, so since the points which are joined are half, 1, and this is 0, 0, so you will be getting the line y equals to 2x. So g 1 by 2 minus x has the equation 2x. Okay. Now, this is 2x, this is 1 minus 2x, and this is 2x. You'll add them, you'll be getting a 1, which is between 0 and half. So you get 1 here. And rest everywhere, the function is 0. So that means the range. What is the range of this h function now, which is the sum of gx plus gx and g 1 by 2 minus x? The range is just 0 and half because it is not taking any other value except 0 and 1. Sorry, 0 and 1. Because after half also it is 0, before 0 it is 0, and between 0 and half it is taking the value 1. So hx has the range 0 and 1. So P has the option 5. So we can easily eliminate the A and D options. Either B is correct or C is correct. Okay. Now, which is the easiest part out of P, Q, and R and S? You can see that in the S part, they are asking all to be 0 and only D is 1. This means A0, B0, C0, and H is only GX. H is only GX. So they are also saying that G is either 3, because we, using the P part, we could say that P is taking the fifth option. So either this is right, or C option is right, or B option is right. Now, S is the easiest of all, because this is the H is nothing but the function G only. So if we are able to find the correct answer for G, we'll be able to solve this question. Now they're saying that is G differentiable on R, because H is just G when D is equals to 1, or the range. Okay, now you can see, and I told you that this function was not continuous at the value 0. This G function was not continuous at value 0 because there is a break here. Rest of, at all the points, G is a continuous function. So that means at the value 0, since the function G is not continuous, we can't talk about differentiability, because continuity is a necessary condition for differentiability. So we can't talk about differentiability because we know that G is not continuous on and the entire real line. 0 is the point of, at 0, G is discontinuous, or 0 is giving the point of discontinuity. So that means we know that this is not right, because H is not differentiable on R, because H is not even continuous at 0. So that means for S, fourth is the right answer. And we can easily see that using the graph only of G, between 0 and half, G is taking the value between 0 and 1. You can see all the values are taken between 0 and half, between 0 and 1. So Gx is taking all the values between 0 and 1, when x is lying between 0 and half. But for the rest values, G is 0. So that means, what is the range? It is nothing but 0. 0 close interval 1, because 1 is also attained by G at the point of domain 0, and 0 is attained by G at half, and as well as for all the points of the domain except this closed interval of 0 and half. So that means G, the range of G is 0, closed interval 0, 1. So S is mapping to the fourth part, and hence C is the correct answer. So we have seen that C is the correct answer. But I am not just going to tell you the correct answer. I will be solving both the parts, both the remaining parts, Q and R. And then we'll finally say that our question is over. Right now, we have figured out the correct answer only using the parts of P and S. But let us see what Q and R are giving to us. So for the Q part, A is 1 and B, C, D are all 0. So A is 1 and B, C, D all are 0. So that means H is only the function fx. H is the function fx only. So what should be the correctness? 4 and 5 are already mapped. So we have to see these options. Now using the definition of f, you can see that f is continuous. I told you earlier in the video that f is continuous and f is differentiable at will. I think I didn't tell that differentiability condition, but okay, we can see this, that f is differentiable. Why? Because if you solve for the left-hand derivative, you see that for the values non-zero values, f is continuous, and since it is a product of continuous and differentiable functions, when x is non-zero, so it is differentiable. So the only point which is of concern is 0 again. At 0, we check the continuity, and now at 0 only, we'll be checking the differentiability of this function. And let us compute the left-hand derivative. So this is like, H is going towards 0 from the left hand side. And since we are computing at 0, so x is 0 here. So this is 0, x is 0, and fx is 0 at 0. So this is the function. And for the left hand side, when x is less than 0, and since it is fh upon h, we have to, and h is less than 0, so f is taking the value of minus h square sine 1 by h upon h. This h gets cancelled, and you know that this is going to be a finite value between -1 and 1. H will keep, 1 by h will keep oscillating, but since sine always takes a finite value between -1 and 1, and because of this h, it is going to 0. So the left hand derivative is 0. And similarly, you can compute the right hand derivative as well. You will be getting 0 again. This is also 0. So we can easily say that f is a differentiable function, because for non-zero values, it is a product of two differentiable functions, so it is differentiable there. And for 0, we can easily check using the definition of left-hand derivative and right-hand derivative. And we get that both the left-hand derivative, right-hand derivatives are 0. So f is a differentiable function. So the q part, for the q part, the value is r. 3. Sorry, 3. The value is 3. This is P, this is S, and this is Q. Now only R remains. Now what are they saying for R? A is 0, B is 0, C is 1, and D is 0. So this is non-zero, x minus gx. X minus gx. Okay. Now this is taken only. We have to see whether h is 1, 1 or 1, 2. Okay. It will be very nice if we again draw this function x minus gx. Because that will give us the correct answer. So hx is function x minus gx. Now you know that g is non-zero only for the points this lying between 0 and half, and else everywhere g is 0. So that means if x is lying between 0 and half, then h will be x minus the definition of gx, which is this. So you get 3x minus 1. But if x is less than 0 or x is greater than half, then g is 0. So in that case, hx is just a linear function x. Okay. Now, because g is 0, so x minus 0 is x. Now try plotting it. Only 0 and half, and after you have, so when x is less than 0, it is the line hx is x. When x is greater than half, it is the line again x. So what is h when it is 0? And to draw it perfectly, what is, first of all, we see that what is h when x is 0? This substitute here, you get minus 1. So at 0, it is minus 1. It's minus 1. And at half, it is 3 into half minus 1, which is half. So this is half, and at half, it is half. So this is a linear function. That means the graph will be a straight line. So since you have 2 points, you can join them easily. This is a straight line. Sorry, I'm not able to draw it perfectly, but this is a straight line joining minus 1 and half. And after half also, the function is x. The function is the identity function x. And at half also it is half. And after half it is the identity function. So it is just going to extend like this because it is an identity function. And the for the points of domain before 0, it is also linear function and the identity function. So -1 will get mapped to -1, -2, -2, and this is the way. But for 0, it will be at -1. So you can see that for the values greater than half, it is taking all the values because it is the identity function there. So identity function is onto. So for values greater than or equal to half, it is onto. Hx is onto. Or hx is taking all the values. But for the values which are less than 0, also it is taking all the negative values. It will be covering all the negative real numbers. But when x is between 0 and half, you see that here, which is 1/3, between 1/3 and 1/2, hx is taking all the values between 0 and half also. You see that this is 0, this is half. After half, it is also taking all the values because it is the identity function. And between 1/3 and half, also the hx function is taking all the values between 0 and half. 0 and half. And between 0 and 1/3, it is taking some negative values. And you know that after 0, before 0, it is the identity function. Now you can easily see that -1 is also taking the -1 value, and at 0 also h is taking -1 value. That means it is not a 1-1 function because two distinct points are giving you the same value, but it is an onto function because after half you are getting all the values because of the identity function. It is just an identity function, and before 0, for the points of domain which are less than 0, you're getting all the negative real numbers as the image points of h, and between 1/3 and half also you are getting all the values between 0 and half. And between 0 and 1/3, h is taking some negative values. That means h is not 1-1 because you are getting the negative values for the points which are less than 0, and also between 0 and 1/3, you are getting negative values. So h is not a 1-1 function, but it is an onto function. So matching with the correct answer, you get that h is onto, but h is not 1-1. So R is 2, and C part is the right answer. Thank you so much for your time. Happy learning.